Hi everyone, in this video we will discuss using run charts in Minitab, what they are and how to interpret the results. So let's start with the basics. What is a run chart? So a run chart is a graphical tool that plots data in time order against a center line, and it is used to detect non-random patterns in a process. There's a lot to unpack in this definition and we'll get to it shortly. But first, let's look at some scenarios where you could use run charts. So, a hospital, for example, in the healthcare industry. A hospital could track patient wait times in an ER over, say, 60 days to determine if a new triage process actually changed performance or if the fluctuations in the process performance were just random noise. In the food service industry, let's say a pizza chain restaurant could track delivery times for every order across 50 consecutive days to determine whether the delivery process is stable or if it was showing non-random behavior. In call centers, your call center manager could track average handle time after a new call script was introduced, and they could determine whether the AHT actually shifted or if it was the same process with normal variation. Right, now going back to the definition, let's understand some of the key terms here. Let's start with time ordering. Right, what time ordering means is that the data for the run chart must be plotted in the sequence in which it was collected. So observation 1 first, observation 2 second, observation 3 third, and so on. Right, so run charts are fundamentally about sequence. If you jumble the sequence or shuffle the sequence, you would end up sort of destroying the patterns, the trends, the clusters, the oscillations that the chart is designed to detect. So this is what separates a run chart from a simple scatter plot or even a histogram. It preserves this time dimension. So I've listed a patient's temperature log as an example. Right. So to think about it, you would, if you're tracking something like a patient's temperature, you would never be able to spot if the fever was rising steadily over, say, 6 hours or 8 hours, something like that. That time order is the signal. And that's why when you collect data for run charts, that's the first requirement. You've got to make sure that the data collection is time ordered. The next important thing to understand is that in a run chart, the center line is always the median. So why is that the case? The median, as you know, is not sensitive to outliers. So the tests that run chart generates, they assume a reference line where if the pattern is truly random, any given point will have a 50-50 probability of either falling above the center line or below the center line. It's only the median that guarantees this by definition, because a median, it's the center point. It divides the data into two halves, above the median point and below the median point. And by the way, that's also where the run in the run chart comes from. Runs are simply the consecutive points above or below the center line. The next thing to understand is non-randomness. So a stable process will always have a quote unquote unpredictable mix. So some points, as I mentioned, will be above the center line, some will be below the center line, and there will be no obvious structure or pattern when you look at it visually. And that's because some randomness exists in every process within its natural variation, right? If there is non-randomness, that's what run charts are expected to detect. If there is non-randomness, then you end up concluding that something external is acting on the process, whether it's a shift in methodology, procedures, to systems, to processes, to operators, different methods used in production. Those are all external factors which will cause this natural variation to be upset, and that's what will start showing as non-randomness or random or absence of randomness. Now Minitab tests for four things: trends, oscillations, mixtures, and clusters. and it tells you whether the process data has non-random patterns. But do remember one thing, a run chart will only tell you whether a pattern exists. It won't tell you why. The why will be your job as a Lean Six Sigma practitioner or as a data analyst. Now let's look at the 4 types of tests that Minitab performs to determine non-randomness. The first one is trends. So if there are, say, 7 or more consecutive points higher or lower than the previous one, then Minitab starts flagging that as a trend problem. Under normal circumstances, if if the data is truly random, you wouldn't see that happening. For oscillations, Minitab checks if the data alternates above or below the median point too frequently, rather more frequently than random pattern would predict. Mixtures is another test. That's about the data having too many median crossings, more than what chance would predict. And clusters is very similar to mixtures, because what that looks for is if there are too few median crossings. So basically, if there's a clustering problem, then the data would tend to stay stuck on one side of the median, above or below, for very long stretches. And for all of these tests, Minitab will generate a p-value. The null hypothesis would be that the data is random, that there's no pattern, and the alternative hypothesis is that there is a pattern. As always, if the p-value is less than 0.05, we will conclude that the pattern is present, that is, that data is non-random. Now let's switch to Minitab, and here we have Minitab. I have generated multiple data sets. The first thing I'm just going to do is simply copy and paste this data in Minitab, right? And think of these as delivery times for a pizza chain for multiple locations, location A, B, C, and D. So let's just assume that there are 4 pizza stores that collected delivery time for 50 days. And now we can proceed to make the run charts for all of them to determine if the data is random or not. So first things, like I've copy and pasted. Now I just want to create a run chart. So go to Stat, and under Quality Tools, that's the first option there, Run Chart. Click on that. Now there's a dialog box that will pop up. So in this dialog box, what we want to do is data are arranged as single column. Yes, they are. All of the data is in a column. So let's start by selecting location A. The subgroup size would be day, because this represents day. Now there's an option here for data in subgroups. Do you want to do the mean or the median? So for data in subgroups, you can select either, because if in our case the subgroup size is 1, so it wouldn't matter. But as best practice, always choose medians. So click OK and give Minitab a moment to generate the data. I'm going to drag this down so you can see, and let me zoom this just a little bit so it's clearly visible, right? So let's start by reading this output. So on the top, of course, you have a run chart. The data points are connected in time order. There's a center line, which is the dashed line showing the median. Now on the left side, we have a bunch of stats here. So on the left side, the first thing we can look for is the runs about the median, 24. So what this is saying is how many times did the data stay on one side of the median before crossing over. As per this analysis, we've got 24 against an expected of 26. That's pretty close. The longest run about the median was 5, meaning that at most 5 consecutive points stayed on the same side before crossing. So that's nothing unusual. And then 24 is close to 26. So that's why both clustering and mixtures came back as non-significant, no pattern. Basically, these values are greater than 0.05. On the right side, if you look at the right side here, the number of runs up or down, this is about direction. So how many times did the data change direction from going up or down or vice versa? So we've got 35 runs against an expected of 33. So that's why oscillations and trends are both greater than 0.05. The longest run up or down was 4, meaning that at most 4 consecutive points moved in the same direction, that is below the threshold of 7. So all in all, there is no all the p values are greater than 0.05. This process is behaving randomly, and we can now, there's no evidence of anything systematic, right? So this is good. Now we can repeat this process for locations B, C, and D as well. You can either, if you want to repeat the same analysis, you can either go back again to stat and quality tools and run chart, or the shortcut, if you want the shortcut, it's Control E. So if you hit Control E, the same dialog box is going to open. You can leave everything the same, just delete location A. This time let's do the analysis for location B. Again, for location B as well, because the data is collected for 50 days, we don't have to change the subgroup size. And same thing, we are going to leave this checked, plot subgroup medians, and press OK. All right, now let's look at location B, right? It's interesting because this is, just looking at it visually, this is trending upwards, right? On the, this time around, let's start from the right side of this table, not from the left side. So this is the direction which says the number of runs up or down are 9, when Minitab actually expected 33. That's a massive gap. And why were there so few runs up or down? Because the data is going in the same direction, right? So it just keeps going up and up, and the longest run up and down was 17 consecutive points. They were all moving in the same direction. That's why you see consequently the value for trends is 0, which is less than 0.05. So that's a problem there. This is not random. On the left side, if you look, the number of runs about the median are only 2 versus what was expected, which was 26. So the first 25 points here, all of these, they sit below the median, and then the last 25, they are above the median, right? So that's clustering, and obviously if you look at the graph, it visually it makes sense. There's a clear and steady upward trend, so obviously that will naturally split the data into a bottom half and a top half. So and here is an important takeaway. A trend will almost always trigger clustering as well. So these come in pairs often, not always, but often. So the trend is usually the root cause, and clustering is the side effect. Notice also how mixtures and oscillation have a value of 1, right? It makes sense if you think about it, right? The data is trending upward, so it's almost never crossing the median line, right? There's a steady upward trend. There's no crossing. There's no jumping up and down. There's no zigzag. So Minitab is basically asking, is this data crossing this median line too often? Absolutely not. It's crossing it too rarely. That's why mixtures is 1. Same logic for oscillation. There's no zigzagging in the data. It's just a straight upward line. It's the exact opposite. So the data is not changing direction at all. That's why oscillation is also 1. Now again, let's do location C. Same as before, the shortcut is Control E. So when you do that, Minitab will open this dialog box. This time you can just click here, delete location B, and select location C. Same thing for subgroup size, because the data is captured in a way that this column is static for all of these locations. So that's why you don't need to change that. As I mentioned, we leave the plot subgroup medians box checked, and let's click OK, and Let's review this one, right? Now look at this this chart. It almost looks like a sawtooth, right? High low every single time. There is no point in here that stays on the same side of the median as the one before it. Just observe every single point. There's high low, complete zigzag, right? And then if you scroll down here, now let's look at this left hand side. So the number of expected runs about the median are 50 and versus the expected of 26. So in this case, every single point is its own run, and the longest run about the median is just one. So the data crosses the median line far too often, and that's what is called a mixture, and that's why the value for mixtures is 0, which is less than 0.05. And just as we saw with and then let's also look at this right hand side first. Look at oscillations. Again, 0 against an expected number of runs of up and down of 49. 49 are the actual runs up and down against an expected of 33, and the longest run up and down is just 1. So same as the previous location, just the situation is reversed. In this case, basically the data is constantly jumping above and below the median, so it's also constantly changing direction. So in this case, what could it mean if you're like the manager of this pizza store? What could you conclude? It possibly means that there are either two distinct processes, two different operators, different machine usage, different delivery drivers, something like that is happening. That is what's leading to this behavior, right? Now let's lastly do it for location D. Same as before, just press Ctrl E, so your dialog box is going to open up, and we leave everything as is and delete location C and select location D. Okay, now this is an interesting one. In this one, the data is hanging around the median for a while, right? And then it drops for a while, right? So it's here, then it drops, then it picks up again, and then it drops again. And the report, the stats underneath it, they depict the same story. So let's look at the left hand side first. So only 6 runs about the median versus 26 that were expected, and the longest run is 13. And so basically the data is sticking to one side of the median far longer than a chance would predict. So that's what clustering is, and that's why the value is 0 less than 0.05. On the right hand side, it says the number of runs up and down are 31, expected was 33, so that's close enough. The longest directional run up or down is 5, which is below the threshold of 7, so that's why there is no trend or oscillation, but there is clustering in this. So this is what makes clustering different from a trend. With a trend, like in the previous one, here you had in something like this, here you have a trend. In this one, we don't have trends, because with a trend, the data goes somewhere, it climbs or falls. In clustering, by comparison, what the data does is it shifts between levels, but there's no overall change in direction, right? So something in this case, something is causing the process to operate at one level for a while and then shifting to another level for a while. So maybe it's equipment cycling, maybe there's some shift changes, maybe there was a temporary disruption that resolved and then it returned again, some kind of outage, right? So all of these, having done these 4 run charts, we are almost at the end of our exercise. So let's do a quick recap. What's a run chart? It's a simple and simple tool that allows you to get a first look at your process over time. It answers one simple question: is the process performance pattern random, or is something going on? Minitab runs 4 tests: trends, oscillations, mixtures, and clusters. They all work the same way. Count the runs, compare it to what randomness predicts, and will generate a p-value. If the p-value is less than 0.05, you've got a pattern. If not, you don't have a pattern. So that pretty much brings us to the end of this exercise. Hope you found this video useful, and thank you for watching.